When most people think of statistics, they think of statisticians going out into the real world, collecting a sample from whatever population they're interested in, and making a prediction about the entire population based on the measurements they take from the sample. Now, we've talked about in Chapter 1 a little bit about sampling, and we know that a sample has to be random, and we know that a sample really has to be collected in an honest manner, and we know that a sample really has to be big enough. Well, we addressed those first two ideas in Chapter 1, but when is a sample really big enough? Well, we'll address those in the rest of this Chapter 6 and also in Chapter 7. But I do want to talk a little bit about a sample. For example, let's say our population was 100 adults. And let's say I sample that population of 100 adults by collecting a random sample of 10 adults. All right, what are some of the measurements I could take? Well, just right off the top of my head, I can think that we could possibly take the weight of each person in the sample and possibly calculate the mean weight of those 10. Another measurement we could take, we could find their height. And one thing we could calculate might be the standard deviation of their height. A third thing we might do is find the age of each person in our sample of 10. And what we might do is calculate the median age of those 10. In a different view, what we might do is make a survey and ask these 10 people for the election that we just had, who did you vote for? Or we may want to phrase that question so that we have only two possible answers. So we may ask the question, did you vote for Barack Obama or did you not vote for Obama? And the fact we've got two possible answers leads us to a binomial distribution. And usually when we have a binomial distribution, we're talking about a resulting answer in terms of a proportion as a percent. So if 6 of the 10 people in the survey said they did vote for Barack Obama, we could therefore say 60%, or 6 out of 10, 60% of those surveyed did vote for Barack Obama. And that's known as a proportion. Well, the question is, given a sample, what can we expect this sample to be able to say about the entire population? Especially if it's done at random, can we really expect this sample to say anything about the entire population? And the answer is, well, yes, we can. But why can we? Well, that's our discussion for the rest of Chapter 6, and then how we apply it to Chapter 7, and later on Chapter 8. But for now, let's discuss exactly what kind of measurements you can take in the sample that you would expect to be reliable as good predictors for the population at large. For example, the weight. If I take the mean weight of the sample of 10, can I really expect that mean weight of 10 to have any bearing on what the mean weight of the entire population of 100 adults might be? And the height. If I take the standard deviation of their height, can I expect the standard deviation of the sample of 10 to have really any bearing on what the standard deviation of the height of all 100 adults in the population might be? And what was the third one? Age. Can I expect, if I find the median age of these 10, that I can expect that median to be real close to what the actual median age of the entire population is? And finally, about the proportion problem. Can I expect that if 6 out of 10 did vote for Barack Obama, 60%, can I therefore expect that 60%, or at least something close to 60% of the population, did vote for Barack Obama? In other words, how can I take the information from a sample and extrapolate out to the entire population? Can I do that for just any statistic I get from a sample? And the answer is no, not just any statistic. There are just 3 statistics that have been found that we can collect from the sample that are reliable indicators of what to expect about the entire population. And those are, number one, the sample mean. Whatever we get for the sample mean, you can expect to be a good indicator for the mean of the entire population, whatever it is you measured and calculated the mean for. If you do a survey and come up with a proportion or a percent, you can expect that that proportion of the sample, it also can be expected to be a good indicator of the proportion, therefore, of the entire population. And thirdly, you might be thinking standard deviation. No, standard deviation of the sample is not a good indicator for the standard deviation of the entire population. What is valid, though, is the variance. Now, you may or may not recall that variance is simply just equal to the standard deviation squared. And you would think, well, if they're that closely related, if one is good, the other should be good. And the answer, well, no, it isn't. Mathematically, it can be shown that the variance of a sample will be a good indicator for the variance of the entire population, but not the standard deviation. These are the three indicators from a sample that we can use. In chapters basically 7 and 8, we're going to concentrate on these first two, mean and proportion. And by concentrating on that means, we're going to be looking at samples involving mean, samples involving proportion, and see what we can say and how we can say how it relates to the population at large. Now, in related videos, we'll continue our discussion about samples and what else we can say about them and why we can say this is true about mean, proportion, and variance.